Hello everyone. Today we are going to talk about logistic regression. Logistic regression is actually a classification technique and not a regression. What is classification? Classification is basically you want the output in buckets. For example, you may want to you have an email and you want to classify it spam or not spam, or maybe you have pictures of dogs and cats and you want to appropriately label them. um, so basically how logistic regression works is we want our classifier to output values in some buckets. Maybe it's a 0 and 1. So you use some kind of a probability measure. Maybe it's a sigmoid function which should at the end give the probability measure of your and it or it should give a probability for your input features. So logistic regression is a popular method to predict a categorical response. It is basically a special case of generalized linear methods. uh, what are generalized linear methods? Is basically it's a generalization where the error distribution models may be something other than a normal distribution. So it was basically formulated by John Nelder and Robert Wiedenborn as a way of unifying various other statistical models, including linear regression, logistic regression, and Poisson regression. So the loss function is basically the sigmoid function, and now if if the probability is greater than zero point 0.5, the outcome is positive or negative otherwise. Mm, more information about the theory of logistic regression can be looked at in the book The Elements of Statistical Learning. Uh, in this video, we will go through the API of the Spark Logistic Regression API and the new Logistic Regression API as given in the ML uh, package. In the note that also notice as you go through the video that we will not be using the label point, or we will need to enclose our whole data structure as a label point objects. So that is something, if label point has confused you, then that is, so the data flow in the new API will be better. Now let's get into the code. For this video we are going ahead with the stumble upon dataset. So it basically, the dataset will have basically the train.tsv and the test.tsv and the data description. You can take a look at the data description in the stumble upon website of Kaggle. For our feature set, to make this video simple, we have only taken the number of links, number words in URL, parameterized link ratio, and spelling errors ratio. Only these four labels or these four features to build our model. But you can of course go ahead and try with all the feature set as well. Now let's get into the code and create a Spark shell. Great. Let's import the org Apache Spark ml dot classification dot logistic regression, which is an important one. And from classification we will be using the binary logistic regression summary for our summary. For code.org for our evaluation we will be using the binary classification evaluator, and we will need to create the feature, we will need the vector assembler. Now since we have that we have all the libraries classes imported, let's go and co- load the raw data. So in my laptop the raw data is in stumble upon train the tsv, so I will take that data here. This data has headers, so I will basically need to filter out the headers. So these are the headers, and hence I will say that from raw data filter out my headers. Okay, so raw data, and of course I will convert them into, sorry, I will convert them into my records. So since the delimiter here is the tab, sorry, right, let's just see if it's correct or not. It looks great. And now that I have the data, let's look at how this data can be transformed into more manageable bits. So let me take the let me take this first one. Oops. We'll need to define it, and dot, since we have multiple this is basically an array, I will take, and you can see it has all these quotations, so I will need to get all these quotations. So replace all the quotations with nothing, and then my last one is the label. So oops, so I will need to save it. Okay, I've saved it in a variable called trimmed, and I will take this trimmed and my last variable or feature is my label. So I will basically get the label, which looks fine, and feed, sorry, features is trimmed. And since I am only interested in the last 4 features, I will take will slice it from 22nd feature to the n minus 1th, or the size minus 1th feature, as the last feature is basically my label, and then I will map it to. Now what I will do is I will transform it to a double, but this will basically not work, because if you take a look at this data set, you will see that the all the missing values are actually given by like question mark. So I will need to transform this question mark into something tangible. So what I will do is I will say that if d is equals to question mark, then return 0.0, else d dot double. That's fine. So these are my uh, features. Now to combine all of this and bring it into more of a get the all the data in a nice manner, we will create a case class which is basically from here. So it's called an integer, but I will take it as a double. This is also a double. This is also a double. This is also a double, and this is an integer. Now why I'm taking number of links as a double, because otherwise I will need to, this might throw an error if there is a question mark in the number of links section. So that's why I'm just taking an easy route here. So I will convert all the logic that I have till now, so which is that I will basically from each record to I will get the trimmed records, then I will get the label, and I will get the features. I will check if the size is 4, and then I will inject into the stumble upon case class features 0, 1, 2, 3, this is 0, this is 1, this is 2, this is 3, and the last is my label, and close it. Oops. Okay, let me take a look. Oh, got it. Got my error. So it should. Right, now close it. I get my one. So let's take a look at my data. It looks fine. Now we need to change our data to data frame. My data frame is now created. Let me see if it looks good. Yep, it looks kind of okay. I have my number of links, number of words in URL, parameters, link ratio, spelling errors, and the label. And all of these are basically double, while this is an integer. Fine. Now we need to work on tagging the features and creating the assembler. So feature columns is basically I will need to give this, this, uh, these are my feature columns. So my assembler will have the new vector assembler, which has the input columns are the feature columns, and the output column is the features. Right, so I will transform my data frame, data frame to this, and let's see if it's looks. Yes, so features has all the features as vector. So now you should be able to split it. Training data, testing data is df2 dot random split, which is an like a 70-30% split. Right, so training data dot show should give me my, like, it should have the split. Let's see. right? While the main had something around this, so basically a 70% one. So I can now create my logistic regression instance with okay. I think I did not give the new, yes, set maximum iterator, which is only 10 iterations for now. We set regularizing parameter, which is 0.3, and set elastic net parameter, which is 0.8. Now I can create the model, which will basically fit on the training data. Right, my model is fitted. बोलो दे तो पढ़ो. Now since my model is fitted, I can make the predictions right. So predictions right, it's giving me the values. So now to get an understanding of the model, Spark has various APIs that can help us to do that. So training summary is model.summary, right? And the objective history is basically training summary dot objective history. So you can see that it's basically an array of 0.692. So objective history, but for each in your code you can also do something like this, and it will print out the objective history output. So binary summary is the train summary dot as instance of binary logistic regression summary. It will take binary summary as an instance of the binary logistic training summary. So you can easily get the receiver operating characteristic curve, which we can denote here as binary summary dot ROC. So C dot show, it gives me the false positive and the true positive rates. If we can also see the binary summary dot area under ROC is 0.5, which is not good. It is basically like tossing a coin. So another way to evaluate is by creating the binary classification evaluator. Set label column, which is the label. So accuracy is evaluator dot evaluate for predictions. So you can see that it's only like 0.5. So our model is nothing better than random chance. Of course, we have only used some of the available features. You can use more features to get a better model. Other ways of making the model better is by better scaling. In this case, we have just like thrown data into our model without like adequately taking stock of the data. We'll look at those methods in some other videos. Uh, Before closing this video, if you are interested in NLP, please check out my latest book on fast text. Links of the video will be in the description below. If you like this video, please comment. Thank you.